As we said at the end of our last video, part of the reason our game doesn't really even look like Baldur's Gate right now is our camera position. So we're going to make this new look target. It's just an empty game object that I'm going to position it around the shoulder blades. And we're going to drag that into the tracking target, and we're going to change this hard look at to be a rotation composer. And then I'm going to be a little more precise with our damping, setting all of these to 0.2. Now let's go make a new mono behavior script, and this is going to allow us to control our camera so that we can make things look the way we expect with kind of a nice top-down view, and we'll be able to swivel the camera around our player. So we'll make a header for references. In here, we're going to have a serialized field for our Cinemachine camera. We'll just call it Cinemachine camera. Then we'll make another header for our input actions. We're going to have 3 of these because one of them, the input action reference that we're going to call look action, is going to be for the joystick if you're using a gamepad. But if you're using mouse and keyboard, we're going to have 2 different actions we reference. One for the ability to zoom in and out using the scroll button on your mouse, and the orbiting modifier action is going to be for clicking that middle mouse button and dragging left or right so that you can swivel around. So we'll make another header for orbit. We'll have a serialized field float for orbit speed. We'll set this to 180. We'll make another serialized field float mouse orbit sensitivity. I'm putting this at 0.15. Then we'll make another header zoom. This will have a couple of floats as well, one for zoom speed, 0.03, and one for zoom smooth time, 0.08. Now, if you're ever wondering when we do these videos where I'm getting these numbers, I've usually already tweaked these a lot on my own to see kind of what feels close, and that should make it so that you can just follow along with this script, plug in and play, and it should feel decent. But everything is serialized so that if it's not to your personal liking, you can still tweak beyond that. But it should get you close. So we're going to have another header for distance, minimum distance 2, max distance 12. We're going to have pitch by zoom. I'm calling it pitch by zoom because it's the effect where when you're zooming in, the camera starts to also look up. You don't just zoom in while looking down. This is how you get that nice effect in Baldur's Gate 3 of, if I want to zoom way in and almost treat the game like it's a third person over the shoulder kind of perspective, you can get that. But as soon as you zoom out, you get that nice isometric view. So we'll also have a bunch of private floats here for yaw, zoom, etc. Now let's make our awake method. We're going to say if Cinemachine camera is null, Cinemachine camera equals get component Cinemachine camera. And now we'll say that if our Cinemachine camera is not null, we're going to get our orbital follow, which is going to be Cinemachine camera.get component Cinemachine orbital follow. Then we'll say that yaw equals default yaw, zoom equals default zoom, and zoom target equals default zoom. Next we'll say on enable, look action .action.enable, and then we're going to do that exact same thing for the other 2 actions. Zoom action .action.enable, orbit modifier action .inaction.enable, and then in on disable, we're going to do the exact same thing, but using disable. Next, we'll make our update method, and we'll say if orbital follow is null, return. Otherwise, we're going to run this series of methods that we're about to create. Handle orbit, handle zoom, apply camera state. So first we'll do private void handle orbit. We'll say vector2 look input equals look action does not equal null, question mark, look action.action.read value vector2 colon vector2.0. And then I'm just going to drop that down so it's a little easier to look at. Next, we'll say bool is using mouse equals mouse.current does not equal null, and look action does not equal null, and look action.action.active control does not equal null, and look action.action.active control.device is our mouse.current. And once again, I'm just going to drop these down so that it is easier to look at. It's not one gigantic long line. And then we'll say bool orbit modifier held equals orbit modifier action does not equal null, and orbit modifier action.action.is pressed. If is using mouse is true, then we're going to have a little nested if statement here to say that if orbit modifier held is not the case, return. And then we'll say yaw plus equals look input.x times mouse orbit sensitivity. Otherwise, we're going to say yaw plus equals look input.x times orbit speed times time.delta time. Now we'll jump down here and do our private void handle zoom. We're going to say vector2 scroll input equals zoom action does not equal null. And I've learned my lesson. I'm just going to pop down right now. Question mark zoom action.read value vector2 pop down, do a colon, vector2.0. Then we're going to say float zoom input equals scroll input dot y. Zoom target minus equals zoom input times zoom speed. Then zoom target equals mathf.clamp 01 zoom target. Zoom equals mathf.smooth damp zoom zoom target ref zoom velocity zoom smooth time. Then we'll make that last method, not a float, private void apply camera state. We're going to say float distance equals mathf.lerp min distance, max distance, zoom. Float pitch. If zoom is less than 0.5, then we're going to say float t equals zoom divided by 0.5. Then we'll say pitch equals mathf.lerp, close pitch, default pitch, t. Otherwise, we're going to say float t equals zoom minus 0.5 divided by 0.5. Pitch equals mathf.lerp, default pitch, when I stop having a stroke here, default pitch, far pitch, t. Then we'll say pitch equals mathf.clamp, pitch, close pitch, far pitch. And lastly, our orbital follow dot horizontal axis dot value equals our yaw, and our orbital follow dot vertical axis dot value equals pitch, and our orbital follow dot radius equals our distance. And that should be it. We should be able to just jump back into Unity, and this should be working. So let's click on our player, add on this camera script. I'm going to move it around so that it's up by our player move script. We'll drag in our Cinemachine camera, and we'll add the action references. Now, 2 of these aren't going to exist yet, so you need to go in here and make new actions. I'm calling this first one zoom. You just need to make sure it's set to be a pass-through and a vector 2, and then you'll be able to find the mouse scroll button here and choose that. And then make another one that I'm just calling middle mouse. You go into the mouse, find the middle mouse button, and assign that. And then you can assign these actions to those input actions. Everything else here should be all set, so let's just press play and see if it works. Well, the zoom's not working. The zoom's not working and the rotation's not working. I'm an idiot, and in the Cinemachine camera, we need to remember to change this follow to be an orbital follow. Otherwise, this whole system doesn't work. Now that we've changed that, we should be in business. Okay, now when I click the middle button and move my mouse around, it is working, and when I scroll the middle wheel, we are getting some zoom. That's pretty exciting. We can zoom way out and get a pretty much top-down view, which is pretty cool. We can scroll around. Helps to be near the stairs right now if you still haven't placed anything in your world to see that you're actually rotating. But that is working. We can zoom all the way in here and have it be basically like a third-person game, just like Baldur's Gate does. Pretty sweet. And now when we climb down our ladder, we can scroll around like this and see it from the other perspective. Pretty awesome. Okay, well, in our next video, we're going to start looking at some more advanced things that we do in Baldur's Gate, like how they handle jumping. Because jumping in Baldur's Gate is nothing like most other games that have jumping mechanics, right? You have to pick the jump action, and then you have to use this little arc to find your trajectory and all of these things. It's not going to be fully implemented yet because we still have to have things like stats that are going to affect how far we can jump, for example, or feats that impact how far we can jump. But we will lay the groundwork for those things so that when we do implement stats and feats and things like that, our jump will be easily modifiable to work with those new features as we add them. So that is what we will look forward to in our next video. Thanks for watching. Hope you enjoyed this. Please consider subscribing on Patreon or to the YouTube channel if you enjoyed this video and want more videos like it. I appreciate you so much, and I will see you all in the next one.